Okay, so we're going to continue from yesterday's discussion on displaying data. Yesterday we talked about a bar graph and histogram. Today we're going to continue with the line graph, and we're just going to go over this together in our classwork section. Number one, it says use the data to make a line graph, okay? And like I just mentioned, the line graph shows changes in time. So you'll see dates or days of the week, months of the year, actual times of day. Anytime you're looking at the same thing, the number of cans collected, that's just one thing that we're looking at, the cans, and how it changes over time will be a line graph. So when we complete it, like I mentioned yesterday as well, sometimes they may turn it and put your information on the side, not all the time. So, well, for a line graph, I think mostly you'll put your categories or your timeline across the bottom and your frequencies, your values across the side. Now, we want to make sure that we have an accurate graph. So just as I said yesterday, we always start with 0. Okay? But now we need to look at the values that we have and find intervals that are going to help us to cover all of that data. Okay? We know we can't go by ones because the highest value is 200, and that will take forever. Okay, so what do we think would be a good interval for the graph?
100.
Okay, well, if we did hundreds, we would have 0, 100, 200. We'll only have like 2 lines, so we could probably do a little bit smaller than that just to have a little more space. Okay, we could try 50 because they're all in increments of 50 except for the last 2 that are 25. But if we're in 50, we know that 25 would be halfway between the lines. Okay, so we'll do 50. So we have 0, 50, 100, 150, 200, and we'll stop there. Now, for a line graph, what we do is we put the dots where they go over their over the category or the timeline, and then we connect them in a line. So Monday was 100. Tuesday was 150. Wednesday was 200. Thursday was 125. And Friday was 175. Okay, then we connect the dots. We do not start from down there. We start from the first dot and we play connect the dots. Okay? So that's how we make our line graph. We put our dots and then we connect the dots to connect the data to show the trend, to show the pattern of what the numbers did, what happened to the data. Okay? Any questions about that? Now, 2, 3, and 4, we're reading line graphs. And actually, you see that there are 2 lines, so we're actually going to read a double line graph. You can have double line graphs when you are comparing 2 different sets of data. You can also have double bar graphs like we saw in the homework last night. Okay? Number 2, which plant was taller on Tuesday? Which plant was taller on Tuesday? Which plant was taller on Tuesday? Here's our key here. This is plant A. This is plant B. Okay? When you are drawing your line graphs or your bar graphs and you do have if you do have double line graphs and bar graphs, we do want to make sure we use like different colors so we can tell the two apart. Okay? Plant A was taller on Tuesday. We just look at Tuesday and the red dot is higher, so plant A. Number 3, which plant grew more between Thursday and Friday? Which plant grew more between Thursday and Friday? Okay, let's look at those. If we want to know which plant grew more, we actually want to see which one had the steeper climb. So, plant A was at about 2.75, and it went to 3.25, so it went up about half an inch. Plant B was at about 2.25, and it went to about 2.75, which looks like it was about half an inch too. So to me it looks like they grew about the same between Thursday and Friday. They both went up half an inch. Even though A is on top, it was already taller, it didn't really grow more. They grew about the same. So you're looking at the steepness to see which one grew the most. Okay? Any questions about that? Do we see that? When it says which plant grew more between Thursday and Friday, it wants to see which plant height went higher from that point to that point. Okay? Which plant height went higher from that point to that point. This was already higher than this one, but when we look from this point to this point and that point to that point, it looks like it's going parallel about the same amount. One is not steeper than the other. The higher it goes, the steeper it would get. Okay? And they look like they were going about the same time. Okay? So, we'll put that they were the same. Now, number 4 says, which plant grew the most in 1 week? Which plant grew the most in 1 week? Now, how do you think we're going to figure that out? Are we just going to look at which one is higher, which one is taller? No, we can't just look at which one is taller because it might have been taller to begin with. We want to know which one grew the most. So, will we add or which one will we do? If we want to know which one grew the most or which one grew more, we would subtract. Remember that word more than means to subtract. We want to find the difference of the height that it started and the height that it ended. Okay? So that's how we would figure out which one grew tallest. Now, plant A, it was half inch on Monday, and it grew to 3 1/4 inches. Okay, so it went from 0.5 to 3.25. Okay, So that means it grew about 2.75 inches. Okay. Plant B was at 0.75, and it grew to 2.75. So that means it grew about 2 inches. So which one grew the most? Plant A. Okay, so guys, what we're going to have to, when we're reading graphs, when they ask us these questions, we're not always just looking at which one is on top. We have to remember, we have to look at what information that they're asking us for and what information we're given. Here, which one is taller? Yes, that means higher. For which plant grew more between Thursday and Friday, we're looking at the trend. Which one has a higher trend, a steeper line? And you see, for that one, they went about the same amount. So we would say the same. And then for question 4, it says, which plant grew the most in 1 week? We want to look at where it started and where it ended and which one had the biggest difference. Okay? You can also kind of tell by the steepness of the graph as well. But it's better to look through that information and find it where the height that it started, the height that it ended, and find the difference between the two. Okay? So that's drawing and reading line graphs and double line graphs. Okay? Are there any questions about that? All right. The next thing we're going to look at will be a stem and leaf plot. So we're going to continue in our the classwork section of our folder. And we're just going to take a look at question number 1. Okay. Now, if you look down at 2, 3, 4, and 5, it says what is the least value, the mean, median, and mode. You know, we worked a lot on mean, median, and mode, and we should have a pretty good idea on how to do that. If not, we have our chem charts to do that. So what I want to really focus on is how to make a stem and leaf plot. Okay, and we drew an example on that on our on the last chem chart that we have. But just to remind you, remember a stem and leaf plot. What it does is separate the tens and the ones place. Okay, and if we got up into the hundreds, we would separate the hundreds and tens from the ones. But it's just like splitting those numbers in half. Okay. Okay? It's like splitting those numbers in half. And what we're doing, the tens become the stem. And you know, like the stem of a plant, you have a stem and you have all the leaves coming out, but they're all, a lot of them are connected to one stem. That's how this works. The stem would be the tens place, and we will only have 1 for each of the tens place. So the lowest number, what is our lowest number here? Okay, 21. So our lowest stem, it would be in the 20s. So we just write a 2. 1 time is our stem. That means all the numbers that are in the 20s are going to go on that line. Okay? We have 30s. We have 40s. We have 50s. And that's it. Okay? So, All the 20s are going to go on one stem, all the 30s, all the 40s, and all the 50s. Okay? Now, the leaves will be our ones place, and we do want to put them in numerical order. So, starting with the 20 stem, we said our lowest number was 21, so we put a 1 to represent 21. The next lowest is... We're still in the 20s. Make sure we have all the 20 stems. Okay? The next lowest is 22. So we put a 2 to represent 22. Still on the 20 stem. Okay? The next one, 27. So we put a 7 to represent 27. The next one,
28.
We put an 8 to represent 28.
29.
And a 9 to represent 29. So this represents 5 numbers: 21, 22, 27, 28, and 29. Okay? Then we have the 30 stem. What's the lowest 30 number? 30. So we have to put a 0. Okay? 30.
34.
31.
34.
34.
34.
Another 34. Even if it repeats, we have to repeat it. Okay? 35.
36.
36.
30. That's all.
Okay, that's all on the 30 stem. Now the 40s.
40.
We have a 40. 42.
46.
46. 49. And that's it. And the 50 stem, 52. Now, when we want to figure out how much data, how many numbers, because remember when we find the mean, we add them all up and divide by how many we have. Well, if we have a stem and leaf plot, the way we figure that out, we just count the leaves. We don't count the stems because the stem represents all the numbers that are in that place value, that tens place. So we count the leaves: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That means we've covered all our data. And what this has done is kind of like what a line plot does for the lower numbers. As we record it or collect that data, it puts it in numerical order. Okay? So our lowest number is what?
21.
21. Our highest number is 52. We can take those two numbers and find our range. And then we can use this information to find our mean, median, and as well. Okay? To find our median, we can actually count backwards to the middle just like we did with the other numbers. Because this is the highest number and this is the lowest number. Okay? So as we go forward, we go backwards until we meet in the middle. Okay? So we have 2 in the middle, 34 and 34. So if we add that together and divide by 2, we'll still get 34, because we'll get 68 and then divide by 2. So our median would be 34. What is our mode? Which number appeared the most? 34, because we have 2 numbers on the same stem, on the 3 stem. So we can find our median, our mode, our range pretty easily once we put it in order on our stem and leaf plot. And then finding the mean is going through that process of adding everything together and then dividing by how many numbers you're given.
If you was telling over there the leaves are when only with the leaves are when to be most
But remember, this represents the two numbers together, the stem and the leaf represent the number. So 52, it represents 52. Okay? The stem is just so you won't have to write all these numbers out one by one. You just put the stem on it, meaning all the numbers in the 20, and then the ones place will be the leaves. Okay? So the stem is the 10s, and the leaves are the ones place. Okay? And that's how you make a stem and leaf block. We also went through how you read a stem and leaf block. I said we weren't going to go over that, but we actually did because it helps you to see that pretty easily. Okay? Now, the last thing I want to look at, before I move on, any questions about that? Now, the last thing I want to look at is a pictogram. A pictograph is almost what it sounds like, and that is a graph that uses pictures. Okay? And the pictures represent parts of data. And I'm going to try to see if I can lay that down a little bit. Alright, we're going to look at reading a pictograph. So if you will, this will be the next topic, or the next graph in the classwork section. Okay? A pictograph gives you pictures that represent certain amounts of data. So this is Disco Bob's record collection, and each record equals 10 albums. Okay, so under here, and the reason it's lettered the way it is because the activity was like a puzzle, and you'll see that when I pass the rest of that out to you. Okay. But number one, under the first letter, it says, how many albums does a whole symbol represent?
20.
Okay, 20. So that would mean how many albums does a half symbol represent? Half of 20, which is 10. Okay? Now, how many classical albums does he own? Raise your hand. How many classical albums? 60, because you take 20 times 3, 20, 40, 60. Okay? E, how many country albums does Disco Bob own? Okay? Country albums, 20, 40, 60, 80, 100, and then half will be 110. Okay? Now, T says, how many more soul albums than jazz albums does Disco Bob own? How many more? That tells us that we're going to do what? Subtract. That's that key word for subtracting. So how many more soul albums than jazz albums does Disco Bob own?
30.
Okay, help him out. Help him out. 40. The soul albums are 20, 40, 60, 70. The jazz albums are 20, 30. 70 minus 30 is 40. Another way we could have looked at it, this and this will cancel, that and that will cancel, so what's left over would be 40 albums. Okay, and E. Disco Bob paid an average of about $8 for each of his rock albums. How much money did he spend on his rock albums? If he paid $8 for each album, $8. Let's look at what we have to do here, okay? For each album, first we have to figure out how many rock albums does he have? How many albums does he have?
160.
He has 160 albums because each picture represents 20. So he actually has 20, 40, 60, 80, 100, 20, 40, 60. He has 160 albums, and he paid $8 for each. That's what we're going to have to make sure we don't get confused about just counting the pictures as one. We want to make sure we count the pictures by the amount that it represents, and that's what we do here. Okay? I'm going to just go ahead and work that out. So, he spent $1,280 on albums. Okay? So, remembering that each picture represents 20 albums, okay? That's how we read our pictograph. Okay? Are there any questions about those? Now, what I'm about to do now is give you an activity that's going to be your homework for tonight, where we are going to practice drawing and reading your Stemandleaf plot, your pictogram, and your line graph. Okay?